Okay, so copy this down. Substitution is a method used to solve systems that involves substituting values in place of variables. Okay. So the problem we have when we have a system of equations is we have two variables and then two equations. So we want to distill that down to one variable with one equation. We don't want to solve for x and y. We want to solve for x or y and then the other. So with substitution, we can usually do that. Okay. So we'll start off with some easy ones. And we'll do one as an example. Okay. So here we go. Example. Let's say we have something like two equations, y equals 4x. That's our first equation. And y equals negative 6x minus 30. Okay, so we have two equations with x and y. And so this leads to one unique piece of information. In order to solve, say you have two variables, there's something called the fundamental theorem of algebra that this famous mathematician discovered way back in the 1600s. He figured out when you have two variables, two unique variables, like x and y, you need two equations. When you have three variables, guess how many equations you need? Three equations. If you had four different variables, x, y, z, and some other variable, then you need four equations. For every unique variable in your equations, you need another equation. Basically, he proved that that's true. So this is the minimum we can have. Since we have two unique variables, x and y, we got to have two variables. Okay, and it just builds and builds. So when you get into like algebra 2, you may have to deal with three variables, x, y, and z. And yes, you can graph things in a x, y, z. That's a three-dimensional graph. And you would need three equations. Okay, and you can add another variable like time, and that would be 4 dimensions, and you need 4 equations. So this is just the tip of the iceberg. Okay, so we can solve this, and we don't have to graph. That's the main idea. Okay, so we're going to solve this by substitution. So the first thing we want to do, let me just write this. I'm going to work my way down. Is look for variables that are isolated, and we have two. look for variables that are isolated. Okay, so that's what we're going to do. We actually have two variables that are isolated. We got y equals, it's by itself, and then we have y equals here. So what we're going to do is we're going to pick one of these equations and determine, okay, which one's easier to substitute in for? And it's going to be the top one. We want to replace 4x in place of y in the other equation, okay? So this 4x, and just because it's smaller and less complicated, I'm going to pick that one. And that 4x is going to take the place of y in the second equation, okay? That's why it's called substitution. So I'm going to rewrite my equation with just 4x and no y, and then the rest of this equation. And it's going to make it easier to work with. So I'm going to move one step down and do my substitution. So instead of y, I'm going to write 4x equals negative 6x minus 30. Okay? So that's basically known as the substitution. Okay? And how is this equation different from the one right above it? How is it different from this one? What's no longer there? Why? I can't really solve one equation with two different variables, but I can solve one equation with one unique variable, x. So that's why we do this. Okay, so let's write down on the margin here. Once there is only one variable in the equation, you solve it. Once there is only one variable in the equation, comma, solve it. Okay, well, we've done this before. It's nothing too complicated. Basically, we will get rid of, we have variables on both sides. Let's get rid of negative 6x by adding 6x. Okay. That's going to cancel the x on the left, on the right rather, and we get 4 and 6 makes 10x equals negative 30. Okay. Divide by 10. And we get the answer x equals negative 3. Okay, that's one of the answers, one of the solutions. Okay, so we got half of the answer. The x portion of the xy pair is negative 3. Okay, so now here's what we're going to do next. We already got this answer, negative 3, from this equation here. Take the other equation you didn't use. And we're going to substitute again. We're going to write y equals 4 times x, but now we know what x is. What's the answer for x? Negative 3. So we're going to take this top equation, bring it down, and instead of y equals 6x, we're going to write y equals, I'm sorry, instead of y equals 4x, we're going to write y equals 4 times what we know x represents, negative 3. So what is y going to equal? Negative 12. Okay, so there's our second answer. So that means that without without graphing, we get a solution. -3, comma, -12. And we basically figured out that if we graph these two original equations, they would intersect at the location -3, -12. Okay? And we should probably write down a little note about that. We're going to say substitute again to find the second variable. Okay? So that's the method basically. It depends, it varies from equation to equation, but that's more or less how we solve these. Okay. So we're going to do two more, and then the best way to learn this is just practice. So we're going to say solve by substitution. So we're going to be solving this by substitution. Okay, let me pause this. So here is the system we're going to solve. Y equals 6x minus 24 and then y equals 2x. Okay, so you're going to find that substitution method is easiest when you have at least one of these equations saying y equals or x equals. Okay, so our first task, we want to look for a variable that's easily isolated. I would think this one. It's got less stuff. So we're going to take this 2x. And where is it going to go? Replace it here. Okay. So we're going to replace it there. I'm just going to write that next step just to the right. Okay. So I'm going to replace y with 2x equals 6x minus 24. Okay. Didn't do anything. Oh boy. Okay. So we did that substitution. Let's solve it. We'll get rid of 6x. Okay. And let's see what that gives us. 2 take away 6 is negative 4x equals negative 24. Okay. So let's see here. If I have negative 4x equals negative 24, what does x have to be to make that true? Negative 4 times what is negative 24? 6. So we got an answer. Now we're going to take this answer and the other equation we haven't used, y equals 2x, to get what y equals. So if we start off with y equals 2x, but that's going to be y equals 2 times 6. So that makes it y equals 12. And there it is. So the only thing left is to write down our solution. Where will these two lines intersect? 6 and 12. Okay, so that's our answer. Okay. We'll do one more and then we'll get on the assignment. Number 2. Okay. Let's do x plus y equals 0. And our second equation is negative 2 times x plus 5 times y equals negative 28. All right, this one's a little different. We have to do just a little bit more work. So go ahead and write that down. X plus y equals 0. And then negative 2x plus 5y equals negative 28. Neither of them says x equals or y equals like we had before. But taking that first equation, it would be very easy to do that. Okay? So say I wanted to have y by itself. If I want to have y by itself, how would I transform this first equation? What can I do? If I want just the y on the left side. Carlos, wake up. Yes. Yeah, subtract x. So sometimes you're going to have to do a little bit of work. And you want to pick the easiest one to isolate for. So subtract x on both sides. And then that would give me y equals negative x. Okay? So now I can substitute. Wherever I see y, I'm going to put in negative x. So we're going to take negative x into the second equation and plop it in there. Okay? So this is going to go in there. Here we go. Negative 2x plus 5 times negative x equals negative 28. That's the substitution we're going to do, okay? So it's 5 times negative x. And why negative x? Because that's what we isolated there. Okay, so let's go ahead and figure this out. Negative 2 times x is negative 2x. And then what's going to be 5 times negative x? Negative 5x, I'll just write that, minus 5x, equals negative 28. So now we're just using basic algebra skills. Combine negative 2x and negative 5x. That's negative 7x equals negative 28. Divide by negative 7. And we get x equals 4. Okay. So now we figured out what x is. It's 4. Okay. So we went ahead and we figured out x. I'm going to put a little separator here. Okay. So let's take this. Actually, it doesn't matter which one, but yeah. I'm going to take this one that already says y equals. I'm going to take y equals negative x. And I'm going to replace x with 4 because I know that's what x is. Y equals negative 4. That's my answer. So all I did was plop that in. I replaced the x part with 4, but we still have that negative. So it's x is 4, y is negative 4. So the solution is 4, comma, negative 4. And that is what we're looking for. 4, negative 4. That's where the two lines would intersect. Okay? All right. So the assignment is on delta. Let me just, I think I can stop this.